Pre-statistics. Part 3. Lesson objectives. Solve one-variable equations by using a table or graph. State if a solution set of an equation is conditional, inconsistent, or an identity. Lesson objective number 1. To solve an equation by graphing. To use graphing to solve an equation a equals b and one variable x, where a and b are expressions. Number 1. Graph the equations y equals a and y equals b in the same coordinate system. For example, if the original equation is 5x minus 9 equals 3x plus 7, we would graph the equations y equals 5x minus 9, the left-hand side, and then graph the equation y equals 3x plus 7, the right-hand side. Number 2, we find all intersection points. And number 3, the x-coordinates of these intersection points are the solutions of the equation a equals b. Let's do an example. Example 1, solve 1/2 x plus 2 equals negative x minus 1. So our first step is to graph y equals 1/2 x plus 2 and then graph y equals negative x minus 1. So the first equation is the red line. Our y-intercept is 2. Our slope is 1/2. Rise 1, run 2. The blue equation is y equals negative x minus 1. The y-intercept is negative 1. And the slope is negative 1 also. Rise a negative 1, run a positive 1. We see the point of intersection is here. Our x-coordinate is negative 2, as the point of intersection is negative 2, 1. So the solution is x equals negative 2. To check this, we take the original equation. Everywhere we see an x, we're going to substitute negative 2. So here we multiply and then we add 2. This one we take negative 1 times negative 2, and then we subtract 1. So for the left-hand side, we get negative 1 plus 2. Right-hand side, we get 2 minus 1. And left-hand side equals the right-hand side. So x equals negative 2 is a solution. Let's do another example. Solve the equation 3 equals x minus 2 by graphing. So our first step is we graph the left-hand side, y equals 3, and then we graph the right-hand side, x minus 2. The y-intercept would be negative 2, and the slope would be 1. Rise 1, run 1. Point of intersection is 5, 3. So the x-coordinate is 5, so our solution is 5. Solving an equation in one variable by using a table. Solving an equation by using a table is simple. We look for the input, the x, that produces a output, or y, that is the same. Example 3. Some solutions of y equals 3x minus 5 are given in the table. Use the table to solve the equation 1 equals 3x minus 5. If we substitute 1 in for y into the equation y equals 3x minus 5, the result is the equation 1 equals 3x minus 5, which is what we're trying to solve. We see that the output, y equals 1, originates from the input x equals 2. So the order pair 2, 1 satisfies the equation y equals 3x minus 5. We can check this. 1 equals 3 times 2, which is 6, minus 5. 1 equals 1. So this means that 2 is the solution to the equation 1 equals 3x minus 5. Let's do an example using the graphing calculator. Here we have a linear equation. What we're going to do is we're going to graph the left-hand side and the right-hand side to find the solution. So the first thing we have to do is we hit the y equals button. We type in the left-hand side and y1, y2, we type in the right-hand side. We want to make sure that the stat plot is not on. Next we hit graph. Now we can see it's close here, but it's hard to tell exactly where the point of intersection is. So if we hit the window key, that will change our window settings. So if you hit the window key, you should see this. Now this tells us our minimum x value, -10. Our maximum is 10. We really need to change that because what we need to do is just focus in on here. So if you change the x min to 3, the x max to 7, that's going to focus in on this area. And then we also need to expand our y-axis so we can see the point of intersection. So instead of having a y min at -10, I'm going to change it to -1, and then the y max from a +10 to a +25. This is what the graph now looks like. So we can see that the point of intersection is about here. And if we use the trace button, the calculator will identify the point of intersection. So when x equals 5, y for both lines equals 15. So therefore, the solution is x equals 5. Now if we hit the second and the graph key, which is the table, we get this. And if we go down and look, when x is 5, y1 is 15, y2 is 15. This is the only x value where these two y's are the same. Lesson objective number 2. 3 types of equations. A linear equation and one variable is an example of a conditional equation. A conditional equation is sometimes true, sometimes false. The solution is what makes the conditional equation true. If an equation does not have any solutions, we call the equation inconsistent, and we say that the solution set is the empty set. So there are no values that will make the equation true. It will always be false. An equation that is true for all permissible values of the variable it contains is called an identity. This means there's more than one solution. Any value will make the equation true. Let's look at some examples. Example 4. Solve the equation. State whether the equation is a conditional, inconsistent, or an identity. Number 1. 2x plus 1 equals 9. First thing we want to do is subtract 1 to both sides. We get 2x equals 8. Divide by 2. X is 4. The number 4 is the only solution, so the equation is conditional. 4 makes the equation true. The other numbers make the equation false. Number 2, we have 3x plus 2 equals 3x plus 7. We have variables on both sides, so we want to move all the variables to one side. So we subtract 3x from both sides. Now when we do this, the variables cancel and we're left with 2 equals 7. So there's no more variables. This is a false statement. So since 2 does not equal 7, we conclude that the original equation is inconsistent and the solution set is the empty set. Number 3. Our first step is to do the distributive property. We have 2x plus 8 plus 1. Combine like terms. We get 2x plus 9 equals 2x plus 9. If we move the variables to one side of the equation, we see that 2x minus 2x is 0, 2x minus 2x is 0, and we are left with 9 equals 9. Now this is a true statement, and since 9 equals 9 is a true statement, we conclude that the original equation is an identity and its solution set is the set of all real numbers. So for this equation, you put in any value for x, it will always give a true statement. Thanks for watching.